Mhm. Uf, pues sí, tiene que copiar eso, ¿no? Hola, 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 mis estimados aprendices. Espero que estén todo bien y todo azul.
Good morning.
Bienvenidos. Good morning, everyone. I hope you're doing well. Ta, 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 ta.
Buenos días, Mister.
Buenos días, mis estimados aprendices. Tal como ustedes, tal como que pueden ver ustedes, aquí tenemos un compañero suyo que están en vivo, en directo y a todo color, que están emocionados ya porque regresaron a clases. Ellos querían salir de televisión. Okay, welcome everyone. I hope you're doing well. Today I'm going to continue factorizing the trinomials using the completing square method. Okay, in this case we have three different equations, trinomials. Actually, the first one, 5x squared minus 7x minus 6. The second one, 6y squared plus 11y minus 21. And the last one, parentheses, a squared plus 2a second power minus 2 parentheses a squared plus 2a minus 3, okay? In this situation, we must factorize the trinomial, but as soon as you can see the topic of the lesson, we're going to use the completing square, okay? And remember, and just Ana Lucia asked me that question the last class. She said, well, if we really want to use any technique as we wish, well, the answer is if the expression instruction says only factor the trinomial, did you have the free will? I mean, you really want to use try and error technique, go right ahead. If you really want to use completed square, go right ahead. But if I'm specifying using one kind of technique, you must use that technique that I'm specifying. In this case, the three problems we was to solving by the completing square technique. Okay, so remember before to starting to solving these three examples, remember what is the completing square formula. The completing square formula is given by the following expression: x positive negative b over 2 second power subtracting b over 2 second power positive negative c. This is the completing square formula. In this case, the letter b is the number who is next to the linear variable, and the letter c is the independent term. In simple merely words, the number who doesn't have variable, letter x, y, z, or whatever you want. Okay, so let's going to focus in the three exercise. Just at the beginning, we have the expression 5x squared minus 7x minus 6. Remember, the first thing we must do before to apply the formula for completing square, we must make sure the number who is next to the square variable, that's supposed to be 1. In this case, this is not the number 1. This is the number 5. Well, what we have to do. Previously, we're going to take like a common factor, this number 5. I'm going to open parentheses in the original equation. I mean, every one of these terms must be divided by this number 5, because this number 5 is the number who is next to x squared. For that reason, 5x squared divided by 5 will be x squared. Negative 7 divided by 5, obviously we're going to have a decimal number, but we don't want to working with decimal numbers. For that reason, the only thing that we have to do is write the fraction. In simple merely words, 7 over 5x. And same happen with negative 6. If we divide negative 6 divided by 5, that will be decimal number. For that reason, we have to write only the decimal spread, the fraction expression. I mean, negative 6/5. This is the step previously we must perform before to apply the completing square technique. Now, because we have the leading coefficient, I mean the number who is next to a square, this time is the number 1, we can proceed to apply the formula. I mean, I'm going to copy the number 5, I'm going to open brackets. This bracket will protect this completing the square expression, and it's time to apply the formula. Can you hear my voice loud and clear? All right.
Yes.
Okay. So open parentheses, and we're going to copy the letter X. We're going to copy the sign. If you see the formula says positive, negative, depending what sign we're talking about. In this case, it's negative. The next expression, this expression 7/5, must be divided by 2 because the formula says the letter B divided by 2. And if we divide 7/5 divided by 2, we got 7/10. Close parentheses, elevated the second power, and we're going to subtract this answer, B/2 second power. I mean, 7/10 second power, and copy the independent term. The independent term is -6. And we're going to close the brackets. As soon as you can see, we are finally finished the completing square technique. What we have to do, the only thing that we have to do is trying to simplify these two like terms expressions. I mean, we got number 5, open brackets, open parentheses, x minus 7/10 second power, subtracting 7 second power, 49 over 10 second power, 100 minus 6. Okay. And now what will be the next step? Remember, we must apply like terms. In simple merely words, we must add 49/11 and 6. Remember, every time that we have the same sign, the only thing that we must do is add the terms and copy the same sign. For that reason, if we got -49/100, subtracting 6, the final result will be -649/100. Simple merely words, we're going to copy the number 5, open brackets, copy this parenthesis, x minus 7/10 second power, and this subtraction will be given by -649 over 100. Okay. And what we're going to do, what will be the last step? We're going to apply distributive property, but be careful. This number 5 cannot affect the letter x and 7/10 because this parenthesis is overprotected by the second power. The only thing that we must do in this case is express the product. I mean, in simple merely words, 5 parentheses x minus 7/10 second power. However, by the other hand, this 5 can be affected another fraction. I mean, 5 can be multiplied by this expression. And that will be -649 over 20. And this is going to be, my dear students, the answer or the factorization of this trinomial perfect square. Questions? Preguntas? ¿Todo claro? Caballero, ¿todo claro? Okay, let's going to perform the letter B. Same process, same statement. We got 6y squared plus 11y minus 21. Okay, we must factorize in this expression by means of completing a square. However, before to apply this formula, we must make sure the number who is next to the square variable, that's supposed to be 1. No -1, no 2, no 7, no 6, no 11, so on. Okay, and as soon as you can see, the little coefficient this time is the number 6. So we're going to perform the same step in the first one. I'm going to take outside this expression the number 6. I'm going to open parentheses, and the 3 numbers must be divided by 6. Okay, if we have whole number, good for that one. But if just in case we have decimals, all right, leave the answer in fractions. For example, 6y squared divided by 6, that will be y squared or 1y squared. Okay, plus 11 divided by 6 will be one decimal number. For that reason, the only thing that we must do is write the expression using fractions. I mean, 11 over 6y. And 21 divided by 6, that will be a decimal. Okay. However, if we can simplify this expression, -21 over 6, simplifying that expression, we got 7/2. Why? Because 21 can be divided by 3, that will be 7. And 6 divided by 3, that will be 2. For that reason, we can perfectly simplify that expression, okay? Now, because we have this arrangement, I mean, the number who is next to the square variable, this case is the number 1. Now we can proceed to applying the formula from completing a square. I'm going to copy this number 6 over here, open bracket, and now let's going to apply the formula. So as you can see, I'm going to copy y, the sign is positive. The next term divided by 2, if you divide 11 over 6 divided by 2, that will be equal 11 over 12, close parentheses, elevated the second power, and we must to subtract this answer at the second power and copy the independent term with their sign. This independent term will be -7/2. And that's it. We are performing the completing a square technique. What will be the next step? We must reduce this to like terms. I mean, 6 parentheses y plus 11 over 12 second power minus 11 second power will be 121, and 12 second power 144. And we must subtract this value by -7/2. Continue. Lighters, we must add these two fractions. Okay, copy y plus 11 over 12 second power, and we must apply like terms. I mean, -121, excuse me, 720. -121 over 144 minus 7/2 And the result will be negative 625 over 144. Okay. Now, like a last step, we must apply distributive property with this number 6. And remember, this number 6 cannot affect y-axis in neither 11 over 12 because it's overprotected this parenthesis by the second power. For that reason, 6 parentheses y plus 11 over 12 second power minus 6 times 625 over 144 will be equal to 625 over 24. And this is going to be the solution set of the letter B. As soon as you can see, we are repeating the same step. This is a linear step because it doesn't matter how many problems of this kind I'm going to give you. At the end, the process will be the same. Before to continue with the letter C, do you have any questions? No questions? Marcela? No.
No, mister.
Okay, Avi, no
Mister, I
question.
have a question.
Analia?
What happened with
Mhm.
the 7/2 fraction? I didn't understand.
This what where I got 7/2 or what happened with 7/2?
What happened? It
Because
just
we have
disappears. I didn't understand why.
okay. It appears negative 7/2 because if you divide 21 over 6, that will be a decimal number, right? But if you but the fraction 21 over 6 can be simplified because both numbers can be divided by 3. So if you have 21 over 6, simplifying 21 divided by 3, that will be 7. And 6 divided by 3 will be the number 2. Analia. Ok, que son sus compañeras con las que estaba hablando y según ellas usted escuchó. No, no escuchó.
No les escuché nada,
Yo
mister,
sé
para
que
ser
no les
sincera.
escuchó. No le escuchó porque solo está habilitado por aquí, no está habilitado por allá. Tome asiento, hija. Tome asiento. Okay, so did you understand where I got this negative 7/2 before to continue the explanation, Analia?
Yes.
Okay, then you got this fraction, 11 over 12 elevated second power. 11 second power, 121. 12 second power, 144. And we have like terms, these two fractions, negative 121 over 144 minus 7/2. If you use your calculator and you subtract both fractions, this is going to be the answer, negative 625 over 144. Remember, even though these two fractions are negative, remember when we have fractions or number with the same sign, we must add and copy the same sign. That's why negative 121 over 144 subtracting negative 7/2, the result will be negative 625 over 144. And applying distributive property, we got this answer. Got it? Hello, Analia. Hola.
Yes.
Did you understand?
Yes.
All right. Ok, gracias, Alison. Dígale a María del Carmen que no hay problema. All right, let's going to perform the letter C. In the letter C, we have a little bit situation, just like in the last example that we'll solve on Thursday, sorry. If you remember, we have two ways how we can solving this trinomial perfect square. In the long way, and we have the easy way. Okay, in the long way, we must perform the special formulas from factory over here and applying distributive property, applying like terms, and after that, solving or factorizing this expression, okay, using the completing square. But this is the long way. But in the easy way, as soon as you can see inside the parentheses, we have the expression a squared plus 2a, like a square variable, and like a linear variable, we got a squared plus 2a. We can change that complicated expression by another variable. For example, we can say u, variable u, equal, for example, a squared plus 2a. Why is so useful to using this expression? Because of the moment we're going to try to solve this quadratic equation, this the shape of this equation that's just like a little bit complicated. All right, it reducing a simple expression like u squared minus 2u minus 3 is an easier way to see in this expression like this one instead to use the black one, right? And because the maximum number who is next to the square variable is the number one, we can perfectly apply the formula for the completing the square at once. I mean, we got u minus half of the number two will be one, okay? Close parentheses, elevated at the second power, and subtracting this answer at the second power and copy the independent term. In this case, will be -3. For that reason, this expression is given by u minus 1 second power minus 1 minus 3, u minus 1 second power minus 4. However, remember, this is not the definite answer because the original expression is given by a squared plus 2a. I'm going to replace this letter u using the original expression. I mean, we got a squared plus 2a minus 1 elevated second power minus 4. And you're going to ask, okay, mister, is that it? Is that all that we have to do in this expression? Not yet, because inside this parentheses, we got a trinomial perfect square. We must try to factorize the expression once again inside the parentheses, applying once again the completing square. I'm going to use the bracket that will overprotect this expression and applying once again the completing square. We got a plus 1 second power subtracting this answer at the second power and copy this independent term. What we're going to got? 1 second power will be 1. -1, -1, and elevated this expression or subtracting minus 4. -1, -1, that will be equal -2. For that reason, this factorization form will be given by a plus 1 second power minus 2 minus 4. And we got like terms. The answer will be a plus 1 second power minus 6. I'm going to move the camera a little bit downward. Déjenme moverlo. Ahí está. ¿Preguntas? Questions on this problem? Hello? No questions? That's supposed to be one in the single way. But if you really want to solving this problem in the long way, I'm going to perform this same operation, but in this case, using the long way, if just in case you don't want to apply in this case, the substitution of variables. For example, before the solving this expression the long way, remember one of the special formulas, the special products formulas. If we got a plus b second power, that's supposed to be equal to a squared plus 2ab plus b squared. This is one of the special products formula, okay? And the original problem, we got a squared plus 2a elevated to the second power. For that reason, of the moment we're going to solve this expression, will be given by a squared elevated to the second power plus 2 times ab. A will be a squared and b will be 2a. All right. And finally, the last term elevated at the second power. In this case, will be given by 2a elevated at the second power. A squared plus 2ab plus b squared. All right. Continue with this expression. This negative 2 applying distributive property in these two terms. In the first one and the second one. And that will be given by negative 2a squared minus 4a. And finally, copy the negative 3. And finally, copy the negative 3. All right. So what are we going to do right now? Simple. We must try to simplify these expressions. I mean, this is going to be given by equal like second power. Second power will be 8 4 power. 2 times 2 will be 4. 4 what? A squared times 8 will be a cube. Okay. Continue with this expression. 2a elevated second power will be 4a squared. All right. Continue with this expression. We got, going to copy negative 2a squared. All right. Negative 4a and negative 3. And as soon as you can see, we must apply like terms. If we got, for example, there is no like terms over here. We got a to the 4 power plus 4a to the cube power, 4 minus 2, that will be positive 2a squared. Okay, we got negative 4a and negative 3. Okay, and we got, we are simplifying this trinomial of perfect square. We got a squared plus 4a cubed plus 2a squared minus 4a minus 3. What will be the next step? Well, the next step, my dear students, we must do regrouping the terms and trying to factorizing any one of them, applying common factor, and just in case we must to apply the completing square technique, we have to do it. But in this way, we must to apply the grouping technique because there's no possibility we can apply the completing square technique because it's using only in trinomials. But if you see, we got 1, 2, 3, 4, 5 terms, okay? In the next class, because we are almost out of time, we want to perform the, the way how we can simplify this expression. But if you see the difference between the first expression versus the second one, if we're trying to solving this this huge expression, that will be a little bit complicated versus the moment we want to replace the variables. Okay. So guys, do you have any questions before to finish the lesson of this class today?
Mister.
No? Okay. We're going to finish the class right now. All right. And tomorrow we're going to continue simplifying these expressions. Okay. Thank you so much for your attendance. Have a great and wonderful day. Take care of yourself.
Bye, Mister. Have a great
Bye bye.
day.
Thanks a lot. Bye bye.
See you, Mister.
See you.